Okay, we're going to be doing lead code 1385, find the distance value between two arrays. So you're given two integer arrays, array 1 and array 2, and the integer d, right? Return the distance value between the two arrays. The distance value is defined as the number of elements in array 1 such that there is not any element in array 2 where the absolute value of array 1 minus array 2 is less than or equal to d. So here we have array 1 with 4, 5, 8, right? Then for each element in array 1, we subtract through here the absolute value of 4 minus 10, 4 minus 9, 4 minus 1, 4 minus 8, right? And it's what we're doing here, right? You can clearly see that for 4, 4 is what they're describing as a distance value. It qualifies, right? Because the absolute values here are all greater than d, and our d is 2, right? 5 qualifies as a distance value because, as you can see, they're all greater than 2. 8 does not qualify as a distance value because 2 is equal to 2, which is our d, 1 is equal to, and 7, and 0. So you really need to understand what the question is asking. And this took me a while. Like I read it for like 5 minutes, then I understood what they were asking. But so a mistake I made was actually to return the non-distance values. I had a counter which counts the non-distance values, and that's what I returned. But you're supposed to find 4, 5, and 8, not 8. So let's do the brute force. The brute force is we're going to, for each element here, we're going to iterate through here. So this is 2 loops, right? So brute force is obviously going to be quadratic. It's going to be O of length of array 1 times length of array 2, right? So for I in range, length of array 1, for j in range, length of array 2, we calculate and check for a non-distance value. So if absolute, this is how you do the absolute, if absolute of array 1 at I minus array 2 at j, right, if this value is less than or equal to d, then I'm going to have a counter here. Then we increment our counter for, let me call it non-distance values. Non-distance values. So that means that this value of I is a non-distance value, right? Because its value is less, the absolute value of this formula is less than or equal to d. So non-distance values will be plus equals 1. And then we break, right? We don't need to continue going through the rest of them, right? So for example, if we're at 8 and we calculate this, already we know that 8 is not a distance value. So we don't have to continue with this. So that's why we break here. So we break. And then here we return the length of array 1 minus the non-distance values. Let's see. Voila. It works, right? So how do we improve this? We can improve this by, instead of doing a for loop, we go through array 1 and then we binary search array 2, right? But array 2 is not sorted, right? So all we have to do is sort array 2 first, then iterate through array 1 And for each value, instead of iterating through all this, we do a binary search. And this will evaluate to n log n time for the whole algorithm, as long as there's always, as long as there is a binary, as long as there exists a non-distance value, right? So let's do this. So the more optimal approach, it's not so optimal, but more optimal approach, we sort array2. So array2.sort, this is done in place, and it's a quick sort. Then we iterate through array1 and binary search array2 for non-distance values. So we're going to create our variable for non-distance values, which is equal to 0. We initialize it to 0. Then for num in array1, right? We're getting, instead of like using an index, we're just grabbing them individually. So now we binary search for our non-distance values in array2. So I is equal to 0, j is equal to array2, length of array2 minus 1. I do that, okay? Then, while I is less than or equal to j, we get our mid. So mid will equal to I minus j minus I divided by 2. Then we check, right? We check if absolute value of array of num, right, minus array2 at mid is less than or equal to d, then we increment our non-distance values plus equals 1. And in fact, at this point, we can even break, right? Elif array2 at mid is less than our distance. If array2 is less than our distance value, then I is equal to mid plus 1, else j is equal to mid minus 1. Right, so we're just binary searching for each value, and then we simply return length of array1 minus non-distance values, right? Oh, okay. So that means I made a mistake somewhere. Where could a mistake have happened? Let me see. Oh shit, it was supposed to be num. My bad. I wrote D. It was supposed to be num. Right? Supposed to be this num. Because this is what we're looking for. So sorry about that. Okay. Where else did I make a mistake? If array at mid is less than num, then I is equal to it looks fine. Where may I have made is less than or equal to d counter mid length of array 1 minus counter. My difference I see is here. Okay, so I is equal to 0, length of array, less than or equal to, less than. It looks okay to me. I don't see where I made a mistake. I must have made a mistake somewhere, but I can't see it. Am I tired? J minus 1. Oh, the mistake was here. Sorry. This was supposed to be plus, right? Yeah, not minus. Sorry about that. I'm a bit tired. Yeah. So the mistake was here. And also don't forget here, it's less than num, which is what we're looking for. So yeah, sorry about that. I'm a bit tired, but I just binary search this, and yes, so that's the solution. This will be n log n time. Okay, bye.